Oh, this is Robert Cook, and it's 11 o'clock now, so or just shortly after that Central Standard Time. We're going to kick off our webinar. Nikolay will take us through a deck, and if you have questions and answers, or questions, we'll answer the question. Excuse me. Please use the Q&A button at the bottom of the screen for Zoom, and then we'll address those questions as best we can. There may be a time or two where Nikolay will pause and answer questions that have popped up. Otherwise, we'll wait till the end and address any that were not addressed. We also have Yuri Goltsev on as well. He's one of our founders, and he'll help address questions as they come up.
Hi, everyone. Welcome to our kickoff webinar. My name is Nikolay Samusik. I'm the CEO of Parhelia Bio. And today, I would like to welcome you here to present and share our excitement about a new system, commercial instrument system called Omni-Stainer, which is, we believe, to be the first tissue autostainer for all. And what we are doing as Parhelia Bio is that we're trying to bring simple, powerful, and affordable tissue staining automation to every lab, to research labs and to pathology labs. And we've been working over 2 years on various iterations of prototyping and engineering and early access testing. And many of you here, I believe, have been a part of our early access round. And today we are happy to present the next iteration of our instruments, the new designs, the new systems that we are taking all the way to the commercial launch. And our founding team is myself, Gary Nolan, and Yuri Goltsev. Yuri and I met when we did our postdocs at Gary's lab at Stanford University. And we've spent many hours in the lab doing essentially microscopy stains as a part of the development of Codex multiplex staining technology, which then became the foundation of Parhelia Biosciences. And after spending all these countless hours staining samples in the labs, we essentially realized that there's a big problem that essentially there is no autostaining solutions out there that actually fit the workflow of a research lab and that are affordable enough to be adopted by researchers in a regular biomedical lab. And so anywhere we went, we saw the same thing. Everybody whom we talked to in every lab, it was doing microscopy staining by hand, even though the protocols were getting increasingly more complicated. And we saw that as we developed Codex protocol and looked at other complex multi-omics and spatial staining technologies, we saw that for a new lab, say a collaborator lab, to really get trained in a new spatial protocol and a new microscopy technique, it sometimes took anywhere between 2 and 9 months to get a good result. And people would keep coming to us with some questions like, how do you stain this? How do you stain that? Why are we seeing this funky background? And it's so hard to troubleshoot because there are so many steps to every protocol. And we saw many labs not actually adopt the technology at all and sort of drop the ball because they just couldn't get up and running with such complicated protocols like Codex. And we realized that it would be really nice if there was a protocol autostainer out there that would be compact, flexible, and affordable and could just fit on somebody's bench and not waste people's time, and also miniaturize the process in a way that would save the reagents, because we were seeing that people are just wasting lots of reagents by doing pat pen staining, for instance, on a slide, and like pouring 200-300 microliters on top of a pat pen slide. And then repeating that many times. And if we're talking about expensive antibodies, that at those volumes, you're like using hundreds or if not thousands of dollars per run, and it's just we thought there should be a way to make things more simple, compact, affordable, save reagents, automate the process as much as possible. And also, as we started talking to pathology labs around the country, we were surprised to realize that a lot of the pathology labs also don't do autostaining. And the reason for that is that the autostainer machines that are available for the pathology market are really bulky, really expensive, and a lot of the labs don't have the throughput to justify getting a $200,000-$300,000 machine. So they're just doing that staining by hand, as they've always been doing. And but the job market is getting tougher, and it's hard to find skilled personnel to actually implement staining across the country. And so there's a big need for an affordable auto staining solution in the pathology labs as well. And with that in mind, we developed a very simple instrument, actually two instruments, which are both called Omni-Stainer, but one is called Omni-Stainer C12 because it hosts 12 cover slip mounted samples, and it supports cover slip staining protocols such as Codex, especially the old school way of doing Codex stains, but as well as many tissue culture samples are grown on cover slips, and it's a convenient format for a lot of researchers. And then we also developed Omni-Stainer S12, which is essentially its counterpart that's used for staining, that is capable of staining 12 slide mounted samples at a time. And the way we designed those instruments is that they are compact and they fit the size of SBS footprint, which is essentially a footprint of a 96 well plate. It's very compact. And the idea is that you can use that SBS format labware because it's the size of a 96 well plate essentially, and you can put it on the deck of any liquid handler and let the liquid handler automate the staining for you. And by decoupling the sample fluidics, which I'm going to talk about on the next slide in detail, and the liquid handling, we're able to make this process very simple and also very affordable, as I can show you later on. Or we can couple this with some really cool new liquid handlers like Opentrons, which are a lot cheaper than what liquid handlers of the previous generation used to be. And hopefully with that, in that combination, we can bring this sample staining automation to every lab. So just to introduce you to the principles here and show you some details on how exactly Omni-Stainer works, I'm going to start with a cover slip example, and then I'm going to move to the slides and then on the next one. So we've designed this special single-use plastic element that's called support tile. And the support tile has this interesting shape where it's overall square, but it has this curved ramp at the top, which is serves as a receiver for fluids. And then there are these spacers on the sides that hold the cover slip up from the face of the support tile. And at the bottom, there is a wick and this wick is where the cover slip is resting on. So the idea is that you put your cover slip on the support tile, and that creates a thin capillary chamber in between the support tile and the cover slip. The top of the cover slip partially overlaps the ramp, allowing for the liquids to be dispensed into this wedge-shaped wrap container with a special separator in the middle that actually helps direct the liquid flow towards the size of the sample, and that way it essentially rectifies the liquid exchange front. And the tissue sample sits on the cover slip, right? It's a cover slip mounted tissue sample. And so it's incubated in this thin capillary chamber in between the support tile and the cover slip. And the cool thing about the system is that when you add liquids to the top of this staining chamber to the ramp of the support tile, the new liquid instantly goes into the chamber and displaces whatever the old liquid was in the chamber. And then it allows you to incubate your sample for however many long time you need with this liquid chamber, with this new liquid. And then finally, when the incubation is done, you can add a stain, like a destaining or wash buffer, and displace the staining buffer out of the chamber the same way, using this laminar capillary flow principle. And if you don't add anything to the top, nothing comes out the bottom. The capillary force just keeps the buffer in place, keeps the staining buffer in place until it's ready to be exchanged. And that's the coolest thing about this, is how simple and efficient the liquid exchange is. And also that the layer of liquid in which the sample is incubated is so thin that essentially, it measures in tens of microliters, which allows saving lots of reagents when you do staining, because you can just add much smaller amounts of expensive reagents to the sample, and that will suffice to get a good stain. The support tiles then fit within the Omni-Stainer C12. There are special pillars that support them in the air and allow the waste the wicks to get in touch with a special support and wicking mechanism that draws the liquid out. And so the spent reagents from the staining are just accumulated at the bottom of the C12, at the bottom of the Omni-Stainer. And we've provisioned, based on our experience and calculations, we've provisioned for sufficient waste volume to allow for several hundreds of liquid exchanges during one run, which should suffice for most protocols that we can think about. And if we move on to the Omni-Stainer S12, it works very much based on the similar principle of capillary liquid exchange. The setup here is a little different because the glass mounted sample is sitting on the slide. The tissue sample is mounted to the glass slide, and that glass slide sits on top of a shelf which supports it and also provides this wick at the bottom. And then the bottom of the slide is covered with this plastic cover tile, which is again a single-use disposable consumable that we've designed and created and tested. And essentially, the cover tile consists of a specially shaped piece of heat-resistant plastic laminated with 2 strips of low-tack adhesive. And that adhesive plays the role of these capillary spacers, so it raises the cover tile above the slide and then creates this capillary chamber. And again, we've come up with this curved design to the top of the cover tile, which allows spreading the liquid evenly towards the left and the right, and straightening the liquid exchange front, and thereby minimizing the amount of liquid that it takes to completely exchange one buffer for another. And the samples sit within the Omni-Stainer in sets of 3. So there are 4 shelves, and each shelf hosts 3 samples, which makes 12 total. Robert, are there any questions so far in the chat, or is there nothing going on yet?
Nope, no questions yet.
Okay, cool. All right, so moving on, we are offering Omni-Stainer in 2 different configurations in what we call packages or bundles. So there is the manual and the automation bundle that we offer. The idea is that you can take the if you take the Omni-Stainer and you couple it with a solid lid, which is we call the manual lid, then you can do liquid exchanges by hand using a pipette, dispense the liquids just using regular pipetting, and then still benefit from the ease of use and consistency and reproducibility of your staining, and still benefit from saving lots of reagents, but not have to invest into the automation at all. And some people, we found in our experience in the early access run, we saw about 20% of users actually just want to use this instrument manually, and they find sufficient benefits from it to invest in it into acquiring one, even though they don't actually see a need for automation. And that was a surprise to us and really interesting. So for our commercial launch, we really emphasized that we do have a manual pack. And we created a special lid with a Parhelia logo on the top. And it also comes with a bottle of special reagent, what we call a buffer conditioner, which needs to be added at like a 1 to 200 dilution to every buffer that you use in order to optimize the flow through the liquid through the thin capillary and minimize any bubbling that might occur. And then the automation package is essentially combining that same autostainer with a special lid that has holes, or perforated lid as we call it, and that allows now the liquid handler to access the insides of the Omni-Stainer through those perforated holes in an automated manner. So the Omni-Stainer essentially just sits on the deck of a liquid handler, and then the liquid handler does all the hard work of dispensing the reagents into the Omni-Stainer and onto the samples. We provide labware definitions for the liquid handlers that actually tell them the sizes and the dimensions of these custom labware, essentially. And 2 liquid handlers, just like another well plate, just with 12 wells. It's kind of a nice, easy, seamless integration with liquid handlers. And the only question we had to answer doing that is, how do we keep the samples from evaporation, right? So when this labware sits on the deck of a liquid handler, how do we prevent the moisture from escaping through those openings in the lid and evaporating, drying out the samples over time? And we've tried different things and different ideas, and we've found something that actually works really, really well. It's a rather simple invention where we found that we can just add a layer of double-sided adhesive laminated blotting paper. So we essentially glue blotting paper with a double-sided adhesive to the bottom of the lid. And that blotting paper is getting pre-wetted with a squirt bottle before every run. And that layer of wet blotting paper actually creates like a moisture barrier that prevents the samples from getting evaporated. And so we are providing now sort of professionally manufactured blotting paper packs as a part of our consumable packages. And the other thing that we wanted to mention is, and I talked about it, I mentioned this name before, you know, a lot of people who want to get into the automation business, so to say, and, you know, are looking at a system, you know, the natural question is, you know, what kind of liquid handler would you actually couple these instruments with? And we have found this amazing company called Opentrons, which we're very, very happy to be partnering with, and we have ongoing partnership and co-marketing efforts. And we're going to actually be hosting a webinar, a joint webinar with them on October 11th. So please look out for that and register and come talk to sort of both companies at the same time. And the point of Opentrons is that they've developed this very simple, very efficient, and very affordable liquid handling robot that fits, you know, has a small enough footprint to fit on a bench. And it has a nice software and the Python-based API, which allows you to just, you know, write up any liquid handling protocol in a form of a Python script and execute all sorts of very complex protocols. And in partnership with Opentrons, we were able to actually automate a lot of different assays using Opentrons as a liquid handler. And we wrote the scripts that automate things like immunofluorescence, IHC, H&E staining, Opal, Codex, Catfish, RNA scope, and even heat-induced antigen retrieval. And I'm going to give you a little demo of how this works. So this is actually Omni-Stainer sitting inside Opentrons. And you can see the robot picking up the pipette and going to a 12-well trough reservoir and picking up liquid, the blue dye, and then dispensing that liquid into the cover slip, which sits on top of the support tile. And now with a series of a couple of washes, it gets all the blue liquid out of the chamber. And you can see the waste collecting at the bottom. And here is a quick demo of how slide staining works. Now, instead of doing it robotically, this is done by hand. You can see how efficient liquid exchange is. The front of liquid exchange is pretty flat, thanks to the curved top of the cover tile. And then here's the lid. So once you've exchanged the liquids, you close the lid and you let them incubate in the self-contained humidity chamber. And then finally, something really interesting that we came up with, and something that we're really proud of, really, is this idea that you can not only just do liquid exchanges on the liquid handler, but you can also utilize the heat module or the thermal block to do heat control protocols, right? So Opentrons actually has a thermal block, which has a working range of between 4 and 95 degrees Celsius. And we've designed this special module, which we call thermal sheath. So it's essentially just like a plastic sheath that goes on top of the Omni-Stainer. And then this whole construct goes on top of the thermal block. So the thermal block is heating the Omni-Stainer from below, from beneath, and then the thermal sheath is helping maintain that temperature within the Omni-Stainer. And in order to prevent evaporation when we work with high temperatures, so when we go to 95 degrees range, for instance, to do heat-induced antigen retrieval on our samples that are sitting in the Omni-Stainer, we need to control the humidity very, very tightly, because at that point evaporation becomes a big problem. And just having the wet filter paper alone doesn't necessarily prevent evaporation completely. So we've come up with a system where the thermal sheath includes a special shutter, and the shutter is just like a plastic slider that can go, that has the holes, the perforations that are aligned with the access holes in the Omni-Stainer, but only when the shutter is in the open position. And then when it's in the shut position, then the holes are closed. And there's a special tab here on the thermal sheath that that can be actuated robotically just by the tip of the liquid handler. So the liquid handler goes into the tab and then uses the tip to either pull it open or push it shut. And it will do so in between the incubations, right? In between the liquid exchanges, it will close the shutter and then incubate. Oh, I can see there's a question now. Yeah, so John Frelinger, I'm assuming from OpenTrons, is asking if there are any issues with the tip staying secured when moving the shutter back and forth. Yeah, so I'm going to answer this right now, and just to say, yeah, I don't think we've seen any issues with that. The tip is staying firm and secure because the force that is required to drive the shutter is actually very small. And the two surfaces are pretty well polished together, and it's not a huge force. But yeah, in theory, that could be a concern. So to mitigate that, we do essentially, like, we use a dedicated tip to just operate the shutter. Then we pick it up every time before we need to open the shutter or close the shutter. So we, if the tip falls off, then it's not going to interfere with the rest of the liquid handling protocol. But yeah, it's a good point. We wish OpenTrons include like a tip present sensing, because sometimes we see, very, very rarely, we see a tip fall off just sort of accidentally from the pipette moving around, and that can be that can definitely be a little problematic for long-running protocols. But fortunately it happens like once every blue moon. But maybe next iteration of OpenTrons will include pipette tip presence sensing, and that would make things a little more robust. Okay, yeah, so next one. So just to summarize, we were able to use this system combining OpenTrons with Omni-Stainer to automate a whole slew of different assays. So we've implemented things like standard immunofluorescence, as well as multiplexed immunofluorescence with DNA antibodies, also known as codecs. We've implemented H&E staining. We've implemented IHC, as well as heat-induced antigen retrieval directly on the Omni-Stainer using the heat module. We've implemented imaging mass cytometry staining, and in collaboration with Shahab's lab and Children's Hospital LA. And then we've also implemented Opal, which is this multiplexed fluorescent IHC hybrid system that is assay that is provided by Parhelia Biosciences. And it takes multiple steps of antibody staining and then tyramide deposition and then stripping the antibodies using heat. And so we were able to do it all using the heat control protocols on the Omni-Stainer. And the thing that we ran into when we did our early round of instrument testing was that the users were asking us with, if there was a way somehow to obviate the need to have Python protocols on the OT2, and kind of it seems like there was a little bit of a hesitation for some people to learn how to work with Python and how to sort of modify the Python scripts in order to do the robotic runs. And also, we thought that it would be very nice to just have like a centralized repository of all the protocols. So we've created a piece of software that's called StainWorks, and it's a SaaS software, so it lives in the cloud. And we're going to be offering a free trial account to all of our users. And the idea here is that the software contains a list of we can host a list of different protocols in here. So for instance, we can see there 5, 6 different protocols, which are, each protocol is essentially a Python file. And then the user, I'm actually switch over to like a live demo of this. So if you want to run Codex, for instance, today, you can go to the library of protocols. So this is a global library, and then a user can actually upload their own protocol to their local library or to their user-specific library. So the idea here is that if you want to run a protocol, you can just click on a button, and then the software actually allows you to customize the run parameters for the protocol without having to edit the Python code. So you can set how many samples you want to have in your protocol, whether you're doing FFPE, for instance, in Codex. What is your sample wash volume? What's the antibody incubation volume? So on and so forth. What type of pipette you're using, and so on. And so you can save those run parameters, and then they're just going to be saved in the database in the software, or you can download it, and that way it essentially generates a Python file with all these run parameters written into the file. I'm going to show you how it looks. This is the file that we just downloaded. And so all these parameters here that we've modified through the UI, right, they're reflected in as Python variables. And the cool thing about it is that the system validates the possible ranges or acceptable ranges for every variable. So there's no, that way there's no risk of potentially messing up the settings and putting out like parameters that are not compatible with the actual instrument, and then getting errors or running into problems later on. So this StainWorks essentially is hiding all that complexity of Python programming away from you, and just exposing the necessary parameters as UI values, as UI component controls, and then also holding your hand and only letting you put in only letting you put in the values that are acceptable. So for instance, if I try to put more than 12 samples here, it's not going to let me put more than 12 samples because it knows that this labware can only host labware definition can only host 12 samples at a time. So yeah, that's essentially how staining works is put together. Let me go back to the presentation. Yeah, it's just a very, very simple software, but we thought it has a great potential of making our users' lives much simpler. And then here's, if I share my screen again. Yeah, also, we have a custom protocol development service available. So if somebody wants to create a new protocol or has some kind of an assay they want to automate, we're happy to help with that and provide our expertise. Essentially, to summarize what I've been talking about today, we're very happy, very excited to present Omni-Stainer to the world, which is a result of over 2 years of hard work. And if there's a way to summarize Omni-Stainer in just like 6 statements, we thought these are the statements that actually would describe it the best. So Omni-Stainer is compact, and it's an instrument that has a footprint of a 96 well plate. It's an affordable instrument that starts well below $5,000, which we know is a capital equipment cutoff for many labs, and so we've really determined to keeping that price below $5,000, so that any lab can just order this without having to get a CapEx approval from the grant agency. There's a lot of quite unique technology that went into designing Omni-Stainer, or that came out of designing Omni-Stainer. So we actually have now 5 utility and 4 design patents pending, and we hope that there will be more coming. Omni-Stainer uses capillary staining that essentially utilizes 50% less reagents compared to open top staining, or sometimes 75% less, depending on how low you want to go and how well you want to be like ensuring the washes. But in an essence, Omni-Stainer is saves a lot of reagents, and essentially it pays for itself in reagent savings very quickly. So it works with any SBS format liquid handler. I've talked about OpenTrons today, but we've also tested it with 3 other liquid handlers. We got it to work on Biomech in collaboration with Jared Burks and MD Anderson. And we've also got it to work on Eppendorf's and Hamilton's. So if somebody has one of those, we're happy to also help and set it up. Finally, something pretty unique about Omni-Stainer is that its thermal sheath design makes it compatible with heating and cooling. So you can incubate your samples overnight at 4 degrees, or you can boil them at 95 degrees, or anywhere in between. And essentially, Omni-Stainer saves time, it saves money, and the most important thing is it improves the performance, allowing the lab to get consistent results from day one by just clicking the start button on the instrument, and then walking away knowing that 6 hours later you'll come back and you have your perfect sample staining, without having to spend months of painstakingly mastering the protocol and troubleshooting and wondering why did the background come out too high this time. So no more high backgrounds, no more failed samples, just get your perfect staining every time at the push of a button. And we have a lot of users that have already adopted our technology through the early access round. We've actually had to expand our early access round quite a bit because It seems like people the word started spreading, and people have started sharing the information that there is such an instrument out there. And so we have over 15 active users right now, and they're from lots of very reputable universities and research agencies. And as well as one pharma company, Novartis, purchased an Omni-Stainer. And yeah, so this is very exciting, and we hope that this list is going to grow. And really, thank you very much for your attention and your participation. And I'd like to open this to questions and answers, if there are any.
Nikolay, Ruan has a question. I'm going to take him off of mute. Hang on just a second.
Okay. Oh. Yeah, he's still muted. Did you click ask to unmute? Unmute?
Yep.
Yeah. Okay, Ruan, if you want, you can just chat it in the chat box. Oh, there we go.
Oh, okay. Hi, Nikolay. Great presentation.
Hey, yeah. Good hearing you. Thank you.
I was just wondering, well, through my use of your guys' system, are you guys correct for doing the codex staining when you have the washing steps that you have to use larger volumes of, for example, the washing staining solution, and now you working in this minimal volume amount? How do you correct the reduction in volume? I understand the reduction for the antibody solution, but for those other types of solutions, so if you're using if it only fits like 50 microliters inside a cover slip holder, so how you guys correct that when you're during the staining process, when you're automating it?
Yeah, so the cool thing about that our system is that it's like a flow-through system, right? Yeah. So there is no maximal volume in a sense, right? You can, even though the chamber itself hosts about 50 microliters, you can wash it with 100 or 200 or 300 microliters. And then you can also do repeated washes, right? So you can pass 150 microliters at once, and then you can go and ask the robot to pass another 150 and another 150. So if you really, really want to wash your sample super, super clean, and you don't want to take any risks, right? You can wash, with larger volumes as well as multiple times. But in general, like we've seen that, we just do an iteration of 3 washes with about 150 microliters per wash. But for the antibody staining is when we're trying to keep the volumes low.
I see.
Let me maybe, can you guys hear me?
Yes.
Hello?
Hey, Yuri. Yeah.
Yeah, so yeah, hi, Ron. This is Yuri Goltsev here, one of the co-founders. So the thing is, when you wash your sample, what's important is the ratio between the volume of the wash buffer and the residual volume that is on the sample. In any system, it doesn't matter. You could probably wash with 1 microliter if the residual volume was 1 picoliter on your sample, right? So the exchange in this system is so efficient. It is way more efficient than in any other system when you do manual washes, when you have the dead volumes of 100 microliters, sometimes milliliters. In this system, the exchange front removes all the prior solutions. So really, the residual volume is practically negligible. Essentially, what happens is that in 50 microliters or in 100 microliters, that is roughly the volume of the flow cell, we're washing more efficiently than you are washing, say, the pellet of cells in a 50 ml conical with 50 mL of solution. So that is the reason we can afford to, to reduce the volumes that much. And as a matter of fact, our savings on the washing buffers are just phenomenal, probably 2 orders of magnitude at least. Wow. So we saved 100 times, right? Not that much on the antibody, maybe, but especially on all the washing solutions, we save a lot of them.
Yeah, the saving on the antibody has been great for us in the lab too. We're really saving a lot.
Oh, great! That's good to hear.
Yeah.
But again, the benefit of the system is in increasing reproducibility, robustness, reliability, saving the time. I wouldn't exactly put the antibody saving as the primary objective.
All right. Thanks so much.
Thank you.
Thank you.
Okay, well, there are no more open questions in the chat box. And I don't think, are there any more questions coming through on your end, Robert?
No, I haven't seen any more, Nikolay. We might mention the website and the e-commerce portion of it coming online in the next day or two.
Yeah. So yeah, let me actually just exit this full screen, and then I can. I would like to mention the fact that we're going to have a new website coming on live, and this website is still under development. We still need a couple of days to finalize all the changes, but I can show you this is sort of the best preview that we got so far. Most things here are working, and very excitingly, we're including a 3D virtual demo on our website. That is something, it's like a special demo environment where you'll be able to essentially play around with the Omni-Stainer and see how it works within, how different components of it work, how different procedures are implemented, how to prepare the cover slip, for instance. There's a little bit of a animation that shows you how to like put a droplet of buffer on top of the support tile and then put the cover slip on top. And there's a demo for manual liquid exchange. And there's a demo for automatic liquid exchange. So this is showing you how this works inside OpenTrons, for instance. So you'll be able to access these demos both for Omni-Stainer C12 and S12 through the section of this website here at the bottom, where it says view our virtual demo. And also we've included a rich e-commerce functionality into a website where you can create quotes and as well as order products directly from the website. So you can get the different bundles for different Omni-Stainer types, as well as consumables and the automation protocols, and even OpenTrons. So if you want to order your own OpenTrons robot, you don't have to go to OpenTrons website. You can just order it directly through Parhelia, and it's the same price, and it's just an added convenience for you guys to not to have to place two different orders from two different vendors. You can just get it all from one place. And there's a section on support and resources where we're going to include manuals, and there's a section on the software as well, where you'll be able to access StainWorks software and all the automation templates. So that's about it. Thank you very much for participating. This has been very exciting, and I'm glad to be having you all today with us today. And thanks for following us, and please spread the word and tell your friends and colleagues. And yeah, I'm excited to be on this journey with all of you together. Thank you so much.
Nikolay, Ruan may have one more question.
Oh, okay, cool.
If it's a previous raised hand or not.
I think the hand didn't get unraised.
Okay. Well, if there are no further questions, then we'll end the webinar, and feel free to send us a note, ask us any questions post this webinar via info@Parhelia or sales@Parhelia. And then be sure and check out our website as it comes online. So I'm going to shut down the webinar.